so I'm about to graph x squared minus 4x minus 21. You should instantly be able to recognize this as a parabola, or quadratic, or more importantly, that it is a polynomial. So therefore, it's going to be smooth and continuous. It has one turn. We should be able to identify these things. Our job is just to graph it with calculus. Before we do that, I want to remind you, if we had to graph this before, you would factor it, and then you would find the two zeros, and then you would go, ooh, it's concave up, or because that's positive, then our graph is pointing upward, and then we would sketch it in. We're going to do this a little differently. We are going to find y prime because we want to find the mins or maxes, and we don't know which they are yet. So we take this derivative, 2x minus 4. We set this equal to 0, and then we end up with x equals 4 over 2, which is 2. So now we know that at 2, we're going to have a min or a max. We know it's going to be a minimum, but let's make pretend we didn't know. So then we need to find y prime of 2. No, I'm sorry. We need y of 2 because I want to know the location. I want to know the y value of this min or max. So I'm going to take this 2 and I'm plugging it back in up here. So it's 2 squared minus 4 times 2 minus 21. I do this math, I get 4 minus 8 minus 21, and that's negative 29, negative 25. So I can come down here, I'm going to go negative 25, and I'm going to put my point. Okay. Now, I need to find the concavity, right? Any inflection points. So I find y double prime. Remember, y double prime is the derivative of y prime. Derivative of 2x minus 4 is just 2. This will never be 0. Therefore, and it's defined everywhere, so therefore there is no change in concavity. The concavity is always positive 2, right? So now, and I'm going to do this real formally, when we do our number line, we need to put the number 2 on the number line because of this 2, and we need no number line for our y double prime. So I need to pick a number like 1, something less than 2, to plug in here to see if this is positive or negative. If I plug in 1, 2 times 1 is 2, minus 4 is negative, so I know that it has got a negative slope there. If I plug in 3, I'm going to get 6 minus 4, I'm going to get a positive slope. And I know y double prime is 2, and so I know that this whole graph is concave upward. So from negative infinity to 2, this graph has a negative slope and a positive concavity. That means it's going to have that kind of shape. And then from 2 to infinity, it's going to have a positive slope and a positive concavity. So it's going to have that kind of shape. And this is more or less what we would expect. This is our minimum of our graph. And just to kind of finish this off, just to show how it's still working. Remember, if I were to graph this, I would have factored it the old way. I would have factored this and gone x minus 7, x plus 3, and then I would have realized, oh, I've got zeros at x equals 7 and negative 3. And notice over here, this you could argue is about 7, and this we could argue is about negative 3, but it is certainly symmetric about our vertex, right? This distance here is 5 units, this distance here is 5 units, so like it's working out exactly how we normally graph it. Anyway, there you go.